All right, let's work on problem 3 now. We're going to write a program that prompts the user to enter a number, and then we'll display a message to indicate whether the number is even or odd. And this example is actually in the lecture notes, but let's see how we develop this first with an if statement, and then we'll develop it using a switching case as well to just start getting practice with that syntax. All right, so we've got, then we need user input variable, right? We want to declare that, and so even or odd, we'll still work with an integer, and we'll just call this I value. The user is going to input. We'll prompt the user, enter integer. Right, we're going to read that in with a scanf since it's an integer, right? Our specifier is %d. We then need to store it in the address of I value. Right, so there's our argument here, I value. And now we can determine whether it's odd or even, right? So we say even, sorry. So even numbers have a remainder of 0 when divided by 2. Right. So now here's our if statement. We're going to then check, and we're going to then go ahead and take I value mod 2, right? If that's equal to 0, right, we have an even number, and we can display a message, puts even number. If it's not even, else puts odd number. Remember, put stands for put string. It's going to write the message inside the double quotes and automatically append the new line character to it. Okay, so one important thing to note is precedence. Does this is this of higher precedence than this? It's not, right? The relational operators are of lower precedence, but to be even more clear, right, let's put parentheses around this to indicate that this evaluation will take place before the comparison. So this will then, remember, the modulus operator divides by this number and tells you the remainder. So we should just be able to do build and run. Let me remove the old file from this project. And let's put in an obvious even number. 4 is an even number. All right, then we get the message even number. And again, if we were to then run this with an odd number. All right, 3 is an odd number. And we get that. Okay. Now, that's how we do that with an if statement. Let's see how to do it with a switching case statement. And typically you do something like this with an if statement. Most people tend to do that. It's a little more intuitive to them. But let's look at the switch statement. Keyword switch. And then we want to switch on actually this expression of I value mod 2. So the way a switch statement works is it needs to work with integer or character constants. So we switch, we're going to switch on this expression. This expression will return to 0 or 1. So we have two cases. We have the case, and notice these cases go inside curly brackets. This is part of the syntax of the switch statement. Case 0, right? Well, we would just say puts even number. Same output as we had before. We need a break statement with a switch. And then case 1. This is the case where the remainder is a 1. We'd say puts odd number, right? You don't need to break with a very last statement. We'll illustrate this in a second. Right, the break statement says what will happen is, actually let's just run with the debugger so we can see what will happen. Right, so run the cursor here. Let's make this first one even. All right, so number 4 we saw was an even number. All right, so now we execute this line. 4 divided by 2 is going to return a remainder of 0. So see how it falls into the case 0. This switch case 0 is the same thing as saying up here, if I val mod 2 equals 0. It's just another way of doing it. Like I said, these work really well when we work with some state machines. They work better in some instances than others. You can usually convert, well, you can always convert a switch to an if. You can't always convert an if to a switch, depending on what you're testing. But for simple cases with constants like this, yes, you can convert them to a switch. In this case, if I hit next line, right, we're just going to print out even number. Notice what the break statement does. Now, the break statement means it breaks out of this switch statement and goes to the next statement following the curly. So there's the curly brace that ends the switch statement. So it goes there to execute the next statement following that. Okay. Let's see what happens if I comment out the break statement. What's going to happen is if you don't have a break, once it finds a case that's true, it's going to execute this line, and then it's going to execute every line below that until it encounters another break statement or the end of the switch statement. So run to cursor. Again, we type in a value of 4, the enter key, switch on this. Well, case 0 is true, right? So notice it executes the puts, but notice without the break now, it falls into this case. So it just keeps falling all the way through until it gets to the end of the statement or hits another break. And you get the message both odd and even number. Right? So you have to get used to putting those break statements in there with the switching case. Right. Syntax of the switching case, keyword switch. All the statements need to be in the curly braces here. We call this a case label. So the case statement, like I said, this needs to be a constant value. It could be an integer constant value, it could be a character constant value. And then after this case label, you don't have to have the curly braces again. We could have multiple statements in here, right? I can say puts still an even number. So you can have multiple actions in here without another set of curly braces. Right, run cursor. 4, enter. So next line. See, it keeps falling through until it executes that break statement. And you get both those lines on the output. All right, so there's been a simple example how to solve that problem using both if-else or using the